Okay, we're going to have a little look at some of the Arduino Pro Mini boards, which we use for a number of projects in model railways. The Arduino board basically comes in a anti-static package such as this. You get your header pins here, which you break off and solder into the rows there, or you can solder your conductors directly to the board itself. All these boards that I'll be using are 5-volt 16 meg boards, so they use the ATA 328 processor microcontroller in the center. So take away the bag, and here's one that I prepared earlier. As you can see on the bottom, it's an Arduino Pro Mini board. It's a 5-volt 16 megahertz board. I've soldered the header pins on the board already, and I've soldered the programming pins on there also. To give you some comparison of size, there's an M&M next to the board. So as you can see, I haven't got huge big fat fingers, although some people say they are. Yeah, they're a very, very small board. So a little bit about the Arduino board. And it's the Arduino Pro Mini is a microcontroller board based on the ATmega 328 microcontroller, and it has 14 digital input and output pins. So the pins are multifunction on there. 6 of them can also be used as pulse width modulated outputs. In other words, we can run 3 electric motors off there and vary the speed of them as well. You've also got 6 analog inputs. So your analog inputs could be sensors such as temperature or light. We're going to be using a light sensor in these ones in a couple of projects. It has an onboard resonator, a reset button to restart the program. The 6-pin header programming header here is actually connected to an FTDI cable, which will provide USB power and communications via the USB port on your computer to the actual microcontroller here. They're actually intended for semi-permanent installation, so we're actually going to be putting these in, building them into some building projects later on to control the lighting, and then using the variable light-dependent resistor connected to an analog input to turn the lights on and off at different levels. As I said, there's 2 versions of the board that's available. There's a 3.3 volt version, it runs at 8 meg, that's the speed, and a 5 volt version that runs at 16 meg. These are all the 5 volt versions that we'll be running. Okay, what else can we say about the board? As I said, there's all your input or output pins. If you look at the pin out diagram that's following this, you'll actually see that they are multifunction and can be used for a number of items. There's also a raw data input port as well for controlling other devices that have microcontrollers on their boards, so it can transfer data between 2 microcontrollers. RX and TX data at the top, ground, reset, and then on the side you got VCC, so that's where your power supply connects between the ground connection there and the VCC connection there. You've also got a manual reset, so you can reset the microcontroller via an external push button, which we're going to actually put on the houses, on the models, in a discrete location, so that if the microcontroller does lock up for some reason, you can actually manually reset it without powering down every house on the layout or building on the layout. So there you go, that's the Arduino Pro Mini. Again. Okay, so what we're looking at here is the FTDI processor, or method of programming your Pro Minis. So here's our little programmer. It basically has a USB port here for a micro USB, such as this one. If I turn it up that way, you can see it's the micro USB connection. When you plug the programmer into your USB connection, you should see the RX and TX LEDs that are located here. You should see them pole. Okay, the only other function on the board is this USB, this little jumper here, which you move to either side for 3.3 volt Arduinos, and on the other side for 5 volt Arduinos. As I said, all the ones I'm using are 5 volters, so we'll leave it in that position. So as I said, plugging in the USB connector. If I get it to line up properly. How about I turn it up the right way? Okay, so we plug that in, and you'll see the lights pole. There you go. The Arduino Pro Mini then basically plugs straight into that port and will power the Pro Mini up if you plug it in the right way around. This one wants to be plugged in the other way around, and the light will light up on the Pro Mini saying that the program is actually running. And I believe the program we have running in here at the moment is the blink program, which makes this LED flash at intermittent levels. So there you go, that's the programmer for the Pro Mini. So with this, it'll allow it to connect to the Arduino software and allow you to upload projects into the controller. Okay. Okay, now this board that we've got here is one I've picked up from Tronics Lab in Melbourne, and it's a DC in, DC out power supply. And basically you've got two input pins, positive, negative one side for your DC input, and then positive, negative the other side for the output. Where I'm going to use these devices is to power our Pro Minis. And as we said, these are 5 volt Pro Minis, so I need a 5 volt supply. Now, instead of building a 5 volt power supply and running that all the way around the layout and suffering from voltage drop, I'm going to put a big 12 volt DC power supply in, and wherever there's a Pro Mini, there'll be one of these power supply boards. Basically, I connect the 12 volt DC up to the input, and then using this adjustable potentiometer, if I put it on its side, you'll see it's actually a trim pot. Adjusting that, I can regulate the output to 5 volts. So that means all I have to have is a 12 volt DC supply running around under the layout. Each one of these Arduino boards will have one of these boards with it, which then will have a regulated 5 volt output. So it's a lot of expense to go to, but consider these boards are only $2.50 each from Tronics Lab, and I reckon if you bought them, sorry, they're $4.50 each from Tronics Lab. I've seen them on eBay out of Chinese websites for around about the $2.50 mark. And of course that's Aussie dollars, real money. So if you're one of our friends from across the pond, it will probably cost you less. Not many components on these boards. Basically you've got a couple of big filter capacitors, a couple of discrete components, a big inductor, a trim pot, and there's the heart of it, is this voltage regulator, which is actually connected down to a large chunk of metal under here to work as a heat sink. See if I can get a better shot of that there. So what I do is the back of the board is fairly insulated, is you can bolt that down to something metallic. You can probably dissipate a lot of the heat out of that regulator. I've got a few of them running, and they've been running for about a year now, and I haven't had any problems with the regulator. They are warm to touch, but then again they are a power supply, so they should be warm to touch, otherwise they're probably not working. So that's the DC to DC power supply. Okay, so once you've opened the Arduino software that you've installed from the Arduino.cc website, you'll start up the programmer. This is version 1.67, and it should look something like this. Basically, the first thing we're going to need to do is make sure that the software is set up for the correct type of processor and board that we're going to be using. So if you go to the Tools menu, Board, and then down here are all the different types of boards we're going to be using. We're using the Arduino Pro or Pro Mini, so we'd select that one, and now at the bottom it says here Pro Mini. The other thing we need to do is set up our processor, because the Pro Mini has two different processors, the 5V 16 MHz and the at 3.3 MHz on the AT Mega 323 or the 168 processor. Most of them that you're buying these days are the 328 processors, and I only buy the 5V 16 MHz ones. So we set that there, and now it says down the bottom that it's a AT Mega 328 5V 16 meg. The last thing we need to do is connect the COM port. This one is using COM port 6 on this computer, so we check that, and then down the bottom it tells us the COM port it's actually using. That's basically all the setting up you need to do to be able to talk to any of the Arduino boards. Obviously, if you change the board type from say a Pro Mini up to say the Arduino Uno, you won't have a processor to change, because it's only the one type of processor. You'll just have the COM port that you connected through. It's only certain Arduinos that come with different type processors, and the Pro Mini is one of those. Okay, so this time now we're going to actually load a sketch into the software, ready to upload into one of our boards. So what we'll do first is we'll load an example sketch. As you can see, when you start the software, it comes up with this text. If you basically cut and paste and place your text underneath here, upload the software, every time the processor starts up, it'll run that program once. If you put it between these two brackets symbols, it will actually loop and be repeated. So most of the programs we're going to write are going to be loop type programs where we want them just to keep on going over and over. So what we do is we open up examples, and if we go to our basics first, we'll scroll up the top there, basics, and we'll pick the blink. Now hopefully that's still turning, that's still recording that window. Let's see. There we go, see if it's recording that one. Okay, so what happens here is this is going to turn a LED on for 1 second, then turn it off. Okay, most of these programs when you download them will have some explanation from the person who wrote the code on the top and explain how it's used. So we're using an output, and it's number 13, and basically what we're doing is in between the brackets and we're looping it so it runs over and over again, is we're going to write 13 high, then wait 1000 milliseconds, so it's 1 second, and digital write low, then wait again. Then we're going to go back and start again. So basically this will turn the LED on and off each time we energize it. You can change time delays in here, so it will blink at a quicker rate or it will blink at a slower rate. So very, very simple program, and we'll upload that into a Pro Mini and see it running. Okay, so now we've turned around and we've shown you the blink function. We're going to show you how you upload it to your Arduino. As you can see down here, I've set up my Arduino. It wasn't COM6, it was actually COM18. And you can find that out once you plug your programmer into the USB. If you go to your device manager in Windows, it should give you your COM number. So to upload the program, first we go to the upload button and give that a click. First it compiles the sketch, which you saw. It's not a very big sketch, so it doesn't take long to do, and now it says it's done uploading. If we had a problem during the upload, a red bar would come here that you could click in, which would give you some indication of what the problem is with your program. Some of them take longer. What we'll do is I'll just go and pick out another example, but from the Adafruit ones, which actually run a display. So we'll pick the graphics test. It is a much bigger program than the previous one. As you can see, there's a lot in there. So we'll tell it to upload that into this Arduino. As you can see, we're compiling the sketch down the bottom. Now we're uploading. Takes a little while it uploads. Remember, it's only talking on 2 wires. Now it says done uploading, and the sketch will now be running in my Pro Mini for this graphics test, which we'll use later on when we add the display screen. Anyway. Okay, so here's our Arduino Pro Mini connected to the FTE data loader. And what we're going to do is we're going to upload a project here called Blink. So first off, once you've started the download, the device will need to see if we can get that focused a bit better. It'll need to compile the sketch first. Once it's compiled the sketch, it will then start uploading, and you'll see these RX and TX lights pole here. Once the program is uploaded into the Arduino, it will start running it. You can reset. There's a reset button on the Arduino which you can push it and reset and run the program from the beginning again. So we're just compiling the sketch at the moment in the software, and any minute now it'll start to upload. Here we go, here's the uploading now. As you can see, the lights are polling, and now the light is actually flashing on the front because we've uploaded the blink program. As you saw before, you can change the delay in the blink and how quick it blinks. Anyhow, there you go. Okay, this is the Arduino Uno board, and the reason it's called Uno is Italian for one, and this was the very first board that they brought out. A couple of things to point out. Has a power connector, so you can connect it up to your own power pack, wall wart or whatever. Has a USB socket. If we turn it up that way, You can see the USB socket, it's like a printer port. The actual processor is a plug-in chip this time, so you go your hardest with this one and do all your experimenting, because if you actually do blow the chip up, it's just a matter of lifting up one end, pulling it out and putting another one in there. And they're fairly inexpensive, a matter of $1 or something for a replacement processor. It's got plug ports here. You've got your analog inputs, power, and then all your digital input outputs on that side. The Uno has basically 14 digital inputs and outputs. 6 can be used as pulse width modulated outputs, so you can drive 6 motors, and 6 analog inputs, and it runs at 16 meg. It's got its own onboard quartz crystal to do the timing. Has a USB port, as we saw, and a power jack connection, and it has simple plug-in ICSP headers. As with all Arduinos, it's got a reset button back here, so you can push it and restart the software. As I said, it was called the Uno because it was the first one that they released with the Arduino version 1 software. So if you look on the back there, it actually says it's open source electronic prototyping platform, and that's what Arduino is. It's open source, so anybody can make them. It's not tied into any licensing, and it's a lot of fun. And of course, it's designed in Italy, and therefore there's a little map of Italy next to it. So as I said, with these boards, as with all the others, the beauty about them is you do have socket pins, so using hookup wire with a little prototyping connectors, you can just plug in the board and experiment however you like, connect it all up, make it run. Like I said, if you damage, the only thing you can damage is the actual processor itself, and the processor is easily replaceable. Good fun board for doing experimenting, and if you're going to start off with Arduinos, I recommend that you buy one of these. Okay, the next thing we're going to take a look at, or another item that's useful, is the breakout board. So the breakout board is basically used for experimenting. As I showed you before, with some of the boards, they come with a socket that accepts these pins. You can buy these leads from J-Car already made up with the pins on the end of them. I think it's around about $7 or $8 for about 15 leads, so they're fairly inexpensive. The other item you need is the actual breadboard itself, this device here. And basically what it is an insulated workbench. I've put some rubber feet on the bottom of mine to stop it sliding around the place. But basically it's a grid. You've got columns that are A, B, C, D, E, F, and then you've got numbered rows coming down the side. These pins will plug into any of the receptacles or these little sockets that are in here, and as you can see they stay there quite well. You can also get a component such as an LED and plug those directly into the board as well. So what we could do is we could plug one of our Arduinos with the header. It matches up straight into the socket as well, and now we can pick the pin that we need, plug that in there, put our LED down here. We'll move him over one actually. Put our LED down here, and now we can plug that output into there to turn the LED on and off. So as you can see, we can use it for experimenting. Very easy to make some changes if we do make a wrong connection. If we've got to put a resistor in there, say a light dependent resistor, if we want to experiment in turn something on and off, again. If we put that in there, now all of these, this row here and this row here, are all that conductor, so we can use that as a connection point in our circuit. Very handy device. The board itself is available from Jaycar. As you see, I've got an experiment already set up in there. So if I plug this one back in where I pulled it out, and I just need to pick up a negative, so I can pick any of these ones along that blue run. Let it focus again. Now, if I plug in our programmer, see the lights, the LEDs light up on the board. And something's not right. There we go. To do it again, plug the programmer in. I didn't have the right connection then. Program started and it's loaded the image. Okay. So if I want to make some changes, I can disconnect it, do my changes in my wiring or how I connect the boards together, plug the programmer back in and give it a test. Very, very handy device. The board itself is about $12 from Jaycar, and as I said, these leads are about $7 and you get about 15 in a pack. I've bought 2 packs and I've never run out of cabling. So there you go.